Hello, this is Postdoc Chronicles week number 68, and I need to make this short because I've got to go back to school because later it's Deepak's book launching event. So my supervisor, he wrote a book on experimental physics, and I got to read like majority of it because I was like one of the guys that he asked me to proofread and give some comments and stuff. And yeah, so I'm happy to report that my name is in the acknowledgement section. So that's very nice. But anyway, today we were featuring a game called Inside on the Nintendo Switch by a company known as Playdead, and I know these guys because on the PS Vita I also got to play their game known as Limbo. Okay, and these games are very similar, and I don't want to spoil it to you, like because these games are these are the type of games where you have to get in there blind. You have to let the world immerse you and stuff. But basically, just a very short description that won't spoil anything. It's a 2D puzzle game basically. So you just walk. You have a character. You walk, and then if you got stuck, you move on. But yeah, it's very like weird. There are a lot of like what the fuck moments. Like what like yeah, it's very mind blowing, and they're fairly short. So like 3 to 4 hours. So there are some people who are like, that's a very short game. Like only 3 hours, 4 hours is not worth it. But man, sometimes if the games are like 3 or 4 hours, but they make a lot of impact on you. Like I don't think that's even relevant. As long as the game made an imprint on you, it made an impact. Then whether it's like 10 hours, 50 hours, 100 hours, or just like 4 hours, I believe it's like it makes the experience very dense that way. But yeah, so Limbo, let me just say that Limbo lends a little bit towards the supernatural, okay? And then inside it's a little bit sci-fi, but yeah, Limbo is it's like 2D arts, very nice art style. Inside is still 2D game, but the graphics are in 3D, so you need to check these guys out. Limbo, by the way, is also on the Nintendo Switch. So if you don't have the PS Vita, then you can get it on the Switch instead. But since I already have it on my Vita and already played it on the Vita on the beautiful OLED screen of the PS Vita Fat, then I just got inside on the Nintendo Switch. But anyway, I'm going to post the Chronicles. So again, very quickly, I'm still processing the visa for Switzerland. So hopefully I can make it because there's like 10 days minimum working days to process. I counted the number of working days before my flight, which is October 19. I only have 9 days if I go on Monday, which will be I'm gonna do a walk in. My appointment's supposed to be next Thursday, but if I go on that time, then I wouldn't be able to make it. So they told me to do a walk in. In fact, they advised me to do a walk in now, like as in this morning today. But I told them I can't do that because I still don't have the medical insurance, from Ithemba Labs, the organization that funds us if we scientists go outside to attend some business with CERN. So I just got all the papers like this morning. So now I'm ready to go on Monday. So I'm going there Monday, like before 8 a.m. I should be there already, so that they'll have enough time to process the visa. But Deepak said it should be fine. Like he had some other students who were able to process it in like 3 days, 5 days, because he said basically once you give them the CERN letter, like the letter from invitation letter from CERN, Deepak told me that it's a very powerful thing. It's very basically overrides everything. So once they see that, they're like, oh, the CERN and stuff. So and they're I believe they're also used to processing students and staff going to CERN, because there's an Atlas subgroup here, which the reason why I'm going to CERN is because of the induction for Atlas. So I'll be a member eventually, and yeah, so that's why a lot of people from here keep on going to CERN. At least those people who need to process a visa. My supervisor Deepak, he has like a powerful passport, U.S. passport, so he doesn't need to do the visa thing. But anyway, so I'm doing that, and then on top of it, I'm also reading up on some root tutorials. I was already able to use root. I can use it, but I wouldn't call myself an expert. And yeah, Deepak told me to spend weeks before going to Switzerland, just reviewing root and stuff. So I'm doing that, and I'm also attempting, because I can already actually access the tutorial that's gonna be used. So this thing called Athena. So I'm gonna play around with that, so that if I go there on during the Atlas software tutorial, I won't be going in blind. But yeah, so I'm doing that. On top of that, on the MUED project. So again, I'm still not seeing uncertainty after, compressing the mass spectrum, after mimicking the compressosi, which had the uncertainty on the PT spectrum. So right now, what I did was we had a Skype meeting yesterday with Jong from Germany and Roberto from Spain, and they told me so our last resort is try to use some other generator, like instead of Pythia compared to with Herwig. But one of the things that they asked me to do is instead of simulating the generating the KK gluons and KK quarks on the MAD graph itself, try doing it in the Pythia implementation, because we're not looking at matching anyway. We're just looking at the Parton shower before any application of matching. So just use Pythia without MAD graph. So I did that KK gluon production in Pythia. I edited the spectrum file so that it will have a compressed mass spectrum, but still I was not like I was doing it all night last night. That's the only thing I was doing. But until then, even if I did that just using Pythia, I still don't see the uncertainty. So I'm still waiting for the comments from Roberto and Jong, what they think about it, but I'm still not seeing any uncertainties. Like I said, there's a very little difference that you can force and say it's an uncertainty, but it's not very convincing. And yeah, on the dihiggs project, so my collaborator Subhadip already begun applying, because our cut-based analysis on our dihiggs, the significance it wasn't very strong compared to an existing paper that sort of looks at like very similar final state but on a different signal region. And they did the multivariate analysis using BDT boosted decision trees. And so what Deepak and no, not Deepak, Subhadip. So what Subhadip and I are doing is, so Subhadip had been reading tutorials of the BDT. I was also reading at the tutorials of BDT that is found within the root framework. So what Subhadip did is he used an external BDT. It's called XGBoost, but basically boosted decision tree. What it does is, if cut based analysis in your in discriminating between signal and background does not cut it, then you ask the help of machine learning. In this case, of the boosted decision tree algorithm. So basically, it's like a classifier, because we have a classification problem when you look at when we want to distinguish between signal and background. So given a set of events, you want the machine to classify what is the signal and what is the background. And basically that's what the BDT algorithm does. So it gives you, like, you feed it some kinematic variables that you want to investigate, and then you train it. So you train it on existing background. You tell it, okay, this is a background, this is a signal, and then you feed your region where it's comprised of background and signal, and then you ask it to discriminate you ask it to classify whether it's signal or whether it's background. And then it gives you back a rock curve, ROC curve, and then it also gives you back a list of the kinematic variables that it thinks is the most important in distinguishing signal in background. So Subhadip did that on XGBoost. I'm trying to figure it out on the root. So I'm still, like I said, I'm still not an expert root user. So I'm still reading up. There's like a TMVA classifier algorithm already existing within the root, but then Subhadip emailed like just yesterday. He said maybe I should use also the XGBoost so that I can verify what he did. And also he said he believes that the BDT algorithm found in the external XGBoost is better than the one found within the root implementation framework. So I'm doing that. So I'm gonna read the tutorial that he came out with, and then maybe I'm gonna look at some other signal regions and see if whether or not I get the same rock curves, I get the same hierarchy of the different kinematic classifiers that he was able to use. But anyway, so that's the report for the Postdoc Chronicles week number 68. I'll see you next time, and thanks for watching. Bye bye.